Hi, my name is Brant Red, and I'm going to show you how you can do your own analysis of the COVID-19 data using Tableau. Now, Tableau is a really useful application for doing data analysis and especially visual analysis in graphical form. And there's lots of wonderful tutorials about it out there. My job here is to show you how to load COVID-19 data into there so that you can be looking at your analysis and drawing conclusions accordingly. I also recommend my companion video on how to do data analysis using Microsoft Excel. Now, if you don't have a copy of Tableau, you can get a trial copy from tableau.com. And they also have academic and student plans for that. So we're going to get right into this. The data is posted by Johns Hopkins University on a daily basis, and it's collected from all kinds of governmental and charitable agencies throughout the world. It is right now probably the most authoritative data about the COVID-19 spread across the country. They post that data on GitHub in a GitHub repository, but the format of the data is not convenient for analysis using these kinds of tools. So I wrote an open source program called Read and Convert COVID-19 Data, and that's what we're going to use to prepare the data. It's written as a command line tool to run on Microsoft Windows. If you don't have a Windows computer, most days I post the latest data out here on this web page, brantred.org, COVID-19, and you can retrieve the data from there. Or if you're a programmer and interested in contributing, it's written in C# on the .NET framework. You can probably port it to .NET Core and run it on a Mac or on a Linux machine quite easily. So let's jump right into it. I'm going to bring up our command line. Now, the program is, as I said, read and convert COVID-19 data. And if you run it with the .h option, that's for help, it will give you the syntax of how to run the program. And I'll just go over this really quickly. Read and convert COVID-19 data. -o is for the output, and you give it a file name. The file name should have a .csv extension because it's going to be writing comma-separated values. And then you have some options to control that output. The options are you can filter by a country or region. And in the companion video where I used this with Microsoft Excel, I show you how to filter by country, and I only download the US data. In this case, we're not going to filter, but you could also filter by state or province or by county and district. I recommend if you're doing those sorts of things that you use the higher level filters as well. So for example, you would filter by country, US, state, Georgia. Would be a reasonable thing to do. If there happened to be another country in the world with a state named Georgia and you didn't use the country filter, then you might end up aggregating the data between those two states. County, again, that's even more likely because there are many county names that are repeated across different states in the United States. So you'd want to filter by state and county if you're doing that. We're not going to use a filter today. And but we are going to aggregate and see if these are the aggregations we can do by country, by state, or by county. Region, province, and district are synonymous. They're going to accomplish the same thing because those are combined into the same fields, as you'll see later. So in this case, we are going to aggregate by country. So we're going to be getting countrywide data in our data as we come out of this. So let's put up that command line. So this is read and convert COVID-19 data. The output file is COVID-19 time series world.csv and by country to do that aggregation. And we don't have any filters. We're going to be doing worldwide data today. So here you can see that it's reading the daily reports from Johns Hopkins out there in GitHub. It's read each one of those daily reports, and then it wrote the output to the world time series. I should mention you can have multiple .o options on your command line, so you can read the data once and output different sets of filters or aggregations all in one shot. And that's actually how I do update my web page each day. All right, so that data is in. Let's go to our Tableau application. And we are going to connect to a text file. That's the text file we downloaded. And here it is. This is the time series world. You can see earlier today, I did the US time series as part of my other video. So we're going to open the World Time Series here. One of the advantages of using Tableau over Microsoft Excel is that it treats this as a live data connection. So I can create my visualizations here in Tableau, and then tomorrow I can download the data using the command, repeating the command that I just showed you, and Tableau will automatically update its graphs with the new day worth of data. So here we have then the fields that come in. So you can see county, district, and province, state, or nulls. That's because we said to aggregate this by country. So we're only going to be seeing countries and not counties, districts, provinces, or states. And then let's look at the other data. We have latitude and longitude. The early data from Johns Hopkins did not include the latitude and longitude. If we scroll down a little bit, you can see that it starts to appear in our later data down here towards the end. And this is only a sampling. It doesn't show us all the data points. We've got a lot of data points here because there are a lot of countries. Then we have the total confirmed cases of COVID-19, the total deaths, new confirmed, new deaths, and over here are Delta confirmed and Delta deaths. Those are the changes in new confirmed from day to day, and that can be used for analyzing trends, although we're not going to be doing that in this example, but that's what that information is out there. So we're going to be looking at the total confirmed in deaths and the new confirmed cases. We could look at new deaths if we want to. If you scroll back here, you can see the first few days, we only have data for China, and then going forward, we start to aggregate data for other parts of the world as the virus spread throughout the world. Again, a little bit of a sobering feature to be looking at that. Okay, great. So that's our data. Let's go to a sheet, and this is where we're going to do our analysis. So in this sheet, our columns are going to be the dates. So we will bring in the date into the column field. And by default, this does it by years. Well, that's obviously not what we're looking for here. We're looking at days. Now, there are two places where days show up, on this level and on this level. Now, it turns out here we would be looking at the same day every month, the 8th of each month, the 9th of each month, and so on. And they would aggregate those together. That's not what we want. We want this day down here. This is saying the exact individual day. So we drop that in, and now we can see the whole range of the data, but of course there's nothing in the graph. So now we're going to take our measures, which are down here, and we're going to start with the total confirmed cases. And I'll drag that into the row. Notice that it says sum of total confirmed cases. It's summing up all of those different countries that we listed. So this is worldwide data. Starting with, at the beginning of our data, 555 cases had been confirmed when the data was beginning to be collected, up until the most recent observation, over 1.5, approaching 1.6 million confirmed cases of COVID-19 worldwide. So, and you can see that we have that exponential curve that everybody's been talking about. But what gets interesting is the curve switches to linear in these more recent days, rather than continuing on an exponential path. As scary as this is, and it's certainly scary because that's a steep slope to that curve, getting out of the exponential mode and into a linear mode is still favorable. Now we need to see that level off and taper off, and hopefully we'll be seeing that. I'll show you examples of where some of the countries have indeed started to achieve that as we get into this a little bit further. Okay, so that's the total confirmed cases. Let's add to this graph our total deaths. And so we'll put that. And you can see it does not overlay the graphs because they're on different ranges. The confirmed cases are, here we see 1,500K. So that's 1.5 million is that line that we're looking at here that we've crossed over recently. Here we're seeing 80K approaching 100K. So we're approaching 100,000 deaths worldwide so far. We are at 95,000 deaths worldwide. Very sobering number to consider. And I have to say, for one thing, that's part of my motivation for bringing this data out and helping you analyze it, is so that we can recognize this. But my heart and our prayers go out to all those whose loved ones have been lost and in this. So then let's add to this we're going to add new confirmed cases because that's a trend line that everybody's looking for in hopes of finding the time when we're going to be able to end what I call the physical isolation, because I think in this time of physical isolation, we need to emphasize social connectedness. Even if we're having to connect socially over electronic media, everybody needs those social connections. So I'm advocating for physical distancing and social connecting. So here we have the new confirmed cases. You can see that that slopes up and then is starting to level off. And that's what we're hoping for. We want to see it level off and then decline. It's the decline that we're looking for as it gets back down towards 0 new cases on there. Okay, so we are looking at worldwide. In fact, we could label this sheet world, and we'll do so. So we'll give this a name under rename, and we'll say world. And then we want to duplicate this sheet. So I'll create a duplicate of it, because now let's look at another country. And we're going to bounce between countries. So instead of naming this any particular country like I did if I was retaining it, we're just going to say country. We're just going to be generic here. But I could create one for the United States, one for China, one for Italy, and so on. But right now, we're just creating one for country in general. So we have that. And so in order to filter by countries, we're still looking at worldwide data, of course, right now. We're going to put country or region into our filters. And it pops up and it says, well, what country do you want to look at? Let's start with China, since that's what people have been talking about, and see how China is doing. And we can see China moving along. We see a big spike on one day of new confirmed cases of over 15,000 in just one day when it was trending down. I have to assume that this has to do with some changes in reporting. I don't know that that's the case, but that's what I'm going to assume. And then we can see that curve, just like they talked about in the news. It was getting very steep, and then due to a lot of the measures they took in China, it's then tapered off. And on this line, we can see that new confirmed cases are sub 100 in China, according to the recent reports. And total deaths, again, sloped up and then leveled off, but nevertheless, a very sobering figure of over 3,000 deaths in China. So let's switch countries here. We can just hit that drop down and edit the filter. And let's go look at the United States, where I live. So cruise down here, find US is how the United States is listed in these data, and pick the United States. Now you can see that the United States is still on a slope up, although it's gone from exponential to more linear, and that corresponds to this line leveling out. Leveling out is nice. We want to see that decline if at all possible. Let's look at a couple of other countries that have had a lot of discussion. So let's go to Italy. First, I have to click on none to clear that, and now we'll pick Italy. We're seeing the new confirmed cases declining in Italy down to confirmed cases of 4,200 new confirmed cases. That's still a very high number. And on that same date, you can see total deaths have wrapped up to over 18,000. Italy has been hit terribly hard. Our hearts go out to the folks in Italy, and our hopes of not seeing something like that elsewhere. We also pray for that. So all you Italians, hang in there. Our hearts are with you. Okay, confirmed cases in Italy, over 143,000, and deaths again. Here's the deaths graph, but we were looking at the number when we were hovering there, because this, in the case of Tableau, it shows you all three of our graphs when you hover over any particular date. So there's Italy. Let's take a look at Korea, since everybody's talked about whether the Korean measures have been effective. So again, click none to clear that, and that way we'll get things correct. And let's find Korea here, South Korea, of course. And here we have our South Korean figures. And they had that rapid exponential rise and then leveling off here. And you can see that corresponding in the new cases when things were really taking off, and then they tapered off. And for a long time, Korea was hovering around 100 new cases a day. and then they finally, just in the last week or so, they've been tapering off to now less than 50 new cases in the last 24 hours, and fairly low numbers leading up to that. So Korea seems to be improving a lot in that country. So hopeful signs in Italy and Korea looking really good. Let's look at one more country here before we wrap up, and that is because I happen to have family in Australia. So we'll clear this again, pick Australia, and see how the measures in Australia are working out. And we can see they put some pretty severe controls in place in Australia, and indeed their numbers just over the last, since late March, are declining rapidly. And again, they're starting to see that curve taper off in Australia. So kudos to the folks in Australia for doing what they need to in this difficult time. So hope this is helpful to you, and also hope that by the time you view this and run some analysis that the numbers are looking favorable in your regions. Our prayers go out to everybody involved in this, which is pretty much all of us, but especially to those who have lost loved ones. Thank you.